So this is a really neat question. Again, like a good question that's tough. If I've done my job right, I won't do anything new here, but this is going to be multi-step. I won't be giving you one this tough on the written section of your test. I might feel okay with this as like the nasty. So it says this. Mass 2 is 12.5 kilograms. Okay, I'll label that just so I can see things a bit better. And it says mass 1 is 3.6 kilograms, so it's way lighter. Both are initially at rest 3.2 meters above the ground. Check. It says assume the cord and the pulley are massless and frictionless. Gotcha. If mass 2 is released to fall to the ground, so mass 2 is going to go hit the ground, what's the maximum height that mass 1 will reach? Well, the first thing I'm going to say is if mass 2 goes down 3.2 meters, mass 1 will go up 3.2 meters for a total distance of 6.4 meters off the ground. That's not the answer, but that's my first thought. The problem is when mass 1 gets to its top height, it's going to be moving with a velocity because this has gone down so fast, mass 1 is moving up so fast, it's actually going to enter free fall for a split second and keep going up for a little while. That right there is the maximum height that I want. So I need to figure out that distance right there, the distance between the 6.4 once it gets to the top and how much further it continues just because it's got an initial velocity and it's going to go up into the air for a little while. So I'm going to call this df for distance in free fall, and I'm going to write here df equals question mark. I know at the very, very top, at its maximum height, not VI, Mr. Dewick, let's try that again. At the very, very top, at the maximum height, VF is going to be 0. And I know that it's going to be accelerating at negative 9.8 while it's on the way up after mass 2 hits the ground. In other words, while it's in free fall. Now I'm saying free fall, it's in free fall, but it's moving up. So don't think it has to be moving down. It's accelerating down at 9.8 meters per second squared, but it's in free fall. You know, if I could find the initial velocity, then I could use Vf squared equals Vi squared plus 2AD. I could use D equals Vf squared minus Vi squared all over 2A, and this is the distance in free fall, and then the distance total is just going to be the distance in free fall plus 6.4, its original distance, its original height from the ground. So even though this question is want me to find distance, I'm going to spend some time finding that. How? Well, I think now I'm going to look at while mass 2 is moving down. It seems to me right now that mass 1 has an initial velocity of 0. It says the whole thing starts at rest. This is not that initial velocity. This is the initial velocity in the picture where mass 1 is on the same height as mass 2. And it's going to travel a distance of 3.2 meters up. If I can find how fast it's traveling at the end of that speed when mass 2 hits the ground that mass 1 will be traveling up at, that speed will also be the initial speed in free fall. Hey, you know what? If I can find the acceleration that mass 1, the 3.6, travels at, I'm good to go. I can, in fact, use this same equation. How can I find the acceleration? I can do a free body diagram and winner minus loser. So I'm going to have this M1G tension, M2G tension. I know mass 2 is winning, so it's going to be M2G minus tension plus tension minus M1G equals the mass of both of them times A. Tension cancels. The acceleration that mass 1 is accelerating up at is going to be M2G minus M1G divided by the mass of all. I'm running out of room and I want to keep this all on one page, so I'm going to go to numbers already. 12.5 times 9.8 minus 3.6 times 9.8 divided by 3.6 plus 12.5. 12.5 times 9.8 minus 3.6 times 9.8 divided by, bracket, 3.6 plus 12.5. I get that it's accelerating up. I'm going to write 5.42, but I'm going to keep this number on my calculator. So I get it's accelerating up at 5.42 meters per second squared. 5.42 meters per second squared. Now I can find how fast mass 1 is traveling when it gets to the top. That'll be V final here, which will be V initial when I enter free fall. Okay. I'm going to have to now erase this because I really want to keep this all on one page. So, V final squared is going to be V initial squared plus 2AD. Oh, V initial was that. How do I get rid of a squared? Square root. So the speed that mass 1 is going up at, and also the speed that mass 2 hits the ground at, but I want the one for mass 1 going up, is going to be the square root of 2 times 5.42 times 3.2. 2 times answer button times 3.2 square root. It's going at 5.8882. I'll carry some extra sig figs. 5.888 meters per second. And that's the initial velocity right there, which is going to be going into here. And so now I'll get the distance it travels up in free fall is going to be 0 squared minus 5.888 squared all over 2 times negative 9.8. It's going to be 0 squared minus, answer button squared, divided by bracket 2 times negative 9.8. It's going to continue moving up a distance of 1.77 meters. So how far will it continue going in free fall? 1.77 meters. So I can say 1.77 meters. And if I add that up, I hope I get 8.17 plus 6.4. There it is, 8.17 meters, just like the answer key says. And now I'll do my usual pause and I'll say, hey, did I do anything new there? I don't think I did. It was just multi-step, I think 3 or 4 steps there. Hope that helps.